Hi, this is Mrs. Blake, and today we're going to talk about types of chemical reactions. Classification is the process of putting things into different groups. And if I were to give you guys a pile of buttons that look like the ones on here, some of you would organize these by color, and some of you would organize them by shape, and some of you would organize them by a different characteristic altogether. And you would all be right. So when we classify chemical reactions, you're going to see some differences from one source to another, and it doesn't mean somebody is right and somebody is wrong. They might just be using a different characteristic. One of the more common ways of classifying chemical reactions is to classify them into 5 groups. Synthesis, which is sometimes known as combination, decomposition, combustion, single replacement, which is sometimes called single displacement, double and double replacement. And let's take a look at each one of these kind of individually. So if we're taking a look at this, we're going to start with synthesis. And what do I know about a synthesis reaction? Well, synthesis or combination reaction is when 2 or more reactants are combined into one product. So in a generic statement, we've got an element A and an element B, and through a chemical reaction, they're going to form a compound that's going to be AB. In a real-life example, we can take hydrogen gas, which is a diatomic, and react it with oxygen gas, which is also a diatomic. And if I react them under the right conditions, I'm going to make H2O, which is going to be water. Now, for the purposes of this video, these are not balanced equations. And do know that in real life, yes, you've got to go through and balance the steps to the equation. So synthesis or combination are when 2 or more things are put together to make one. And you're going to find that decomposition is really the opposite of that. So when I take a look at decomposition, decomposition is when one reactant breaks down to form 2 or more products. And so when we take a look in a synthesis reaction, you're going to have 2 or more reactants and one product. And the opposite then would give you one reactant that is going to break up into 2 or more products. So when we take a look at a decomposition reaction, a real life example is, again, you have to have the right chemical conditions. But if I take H2CO3 and I can heat it up, I can produce water and I can produce carbon dioxide gas. And again, not trying to do anything with balancing equations here. So another way to classify, besides synthesis and decomposition, is combustion. And combustion is the burning of a reactant. And usually to burn, you need oxygen. Sometimes you're going to find that people use this for any type of reaction that burns, but more specifically, in the way we're going to take a look at it, we're going to be talking about specifically something known as a hydrocarbon, which is a compound made up of carbon and hydrogen. And there's lots of different hydrocarbons, and that's why you get a generic X and a generic Y, because those numbers are going to change depending on which hydrocarbon you're going to use. Examples of hydrocarbons are things like gasoline and charcoal and propane and butane. And almost anything that you would think of that you would burn will probably be a hydrocarbon. Hydrocarbon reactions look a little bit different. Again, we have some generic number of X and some generic number of Y because it depends on which hydrocarbon you're actually burning. But the part of this reaction that always stays the same is going to be the rest. It is always going to react with oxygen because you cannot burn without oxygen. You are always going to produce carbon dioxide gas and water vapor as this chemical reaction. These chemical reactions are going to be usually at very high heat, but this part of the reaction is always going to be the same. So a real life example is we could use propane, which is C3H8, and it is going to react with oxygen, and it is going to produce carbon dioxide, and it is going to produce water vapor. So, two other types of chemical reactions. We have the replacement or displacement reactions. And replacement or displacement reactions come in a single variety, and they come in a double variety. So if I'm taking a look at single replacement, single implies one, and this is where an element is going to replace one part of a compound. So in this case, I'm going to have an element reacting together with a compound. And so I still end up with an element and I still end up with a compound. Now, this is really going to depend because I can have a metal element or I can do this with a non-metal element, and it looks a little bit different when I take a look at my products. If this is reacting with an ionic compound is always going to be made with a metal, and that metal is always listed first, paired with another non-metal. And so if I have a metal replacing, a metal replaces metal, and in that case, I'm going to end up with a new compound. B is going to be kicked out, and B is going to be by itself, and A is going to come in and form a new compound with C. On the other side of things, we can have a nonmetal. When we have an ionic compound, it's still going to be metal first, and it's going to be nonmetal second. But if I have a nonmetal element, that nonmetal element is going to replace the nonmetal part of the compound. And so my product looks a little bit different. So because nonmetal replaces nonmetal, in this equation, B is my metal, B is still going to be in front, A is going to be my new nonmetal, so there's my new compound, and in this case, C is the one that gets dumped in the chemical reaction. Please remember that in a chemical reaction, it is always going to be a metal first, and in an ionic compound, it's always a metal first, and a nonmetal going to be second. So let's take a look at a couple of examples for each one of these. First of all, if I am talking about my metal replacement, I can have potassium. And potassium can react with something like sodium bromide. Let's go for iron bromide. And in that case, because potassium is a metal, it is going to target the metal in this reaction, and it is going to kick out iron, and poor iron. Iron's going to be the one that's going to be dumped. And it is always going to be metal first. So potassium's going to sit in front, and it's going to be paired with bromine. Now, I do have to make a new compound here, and potassium's a +1 and bromine's a -1, so it does just become KBr, even though there is a 2 here. That 2 actually came from iron. If I have a non-metal replacement, I could take chlorine. And chlorine is a diatomic element, so as an element, it is going to be Cl2. And it can react with, we'll stick with bromine, that's called sodium bromide. And again, because this is metal and metal is first, this is non-metal, it's second. Because chlorine is a non-metal, it is going to replace the non-metal in the compound, it is going to replace the bromine. So bromine is the one that's going to be dumped in this chemical reaction. Bromine is diatomic, like chlorine, so I have to have a 2 with it when it's by itself. But if I'm making a compound and sodium has to stay in front, sodium is a metal and a metal is always in front, chlorine's going to sit where bromine is in the second spot. And since sodium is a +1 and chlorine is a -1, it's just going to be NaCl. Again, you'd have to balance the reaction. So single replacement is when an element is going to replace part of a compound. And we have double replacement. And double replacement is when a compound changes partners. So that if I'm talking about double replacement, sometimes known as double displacement, double replacement is when my positive ions or metals are going to switch partners during the chemical reaction. So in this compound generic formula here, my positive is always going to be in front. It's almost always a metal. So in each one of these, it's going to be positive. And what happens is that positive is going to switch partners. All right, if it's positive switching partners, A is paired with X. And in the new product, A is going to be paired with Y. And in the new product, B is going to be paired with X. Note, you always have to have your positive or your metal first in any particular double replacement reaction. So when I'm taking a look at this, an example reaction of this can be Na2CO3, which is sodium carbonate, and it is going to react with calcium chloride. So in this reaction, sodium is going to be my positive, it is going to be my metal, and calcium is going to be my positive, it is going to be my metal, and that means that sodium and calcium are going to swap spots. So in my product, when this reaction is written then, I'm going to have sodium, but it's going to be paired with chlorine. Now I do have to make a new chemical formula for this, so sodium is a +1 and chlorine is a -1. So it's going to be NaCl, and I cannot steal old subscripts here. I'll use those to balance, but I cannot steal those for my new chemical formula. And then, since sodium is now paired with chlorine, calcium is going to come over and sit where sodium is. Again, calcium is my positive, so my positive or metal has to be in front. And now it's going to be paired with CO3, which is carbonate. And calcium is a 2+ and carbonate is a 2-. And in that case, those charges are going to cancel each other out, and it's just going to be CaCO3. So there's many different ways that we can classify chemical reactions. But the more common way to see chemical reactions is going to be with 5 types. Synthesis, where we put something together. Decomposition, where we take something apart. Combustion is a burning reaction with oxygen to form carbon dioxide and water. A single replacement reaction, where an element replaces another element in a compound. And then a double replacement is where your positives switch partners. All right, thanks for watching. Have a great day.